this series we are discussing the electronic components that are used in the construction of electronic circuit. Today we will discuss one of the important component that nowadays we are doing research on that, and we require this is a requirement of the present scenario, that is a fuel cell. So today we will discuss about the fuel cell. What is this fuel cell? How we prepare this fuel cell? How many types of fuel cell we have? How it works? So we will discuss what is fuel cell. First, what is the fuel cell? Fuel cell is an electrochemical cell. As we discussed the various cells like galvanic cell, primary cell, secondary cell. So one of the important cell is the fuel cell, which is an electrochemical cell that converts the chemical energy of a fuel into the electricity. Means we can get the electricity by converting the chemical energy of the fuel into the electric energy. So fuel cell which converts the chemical energy of the fuel into the electricity by using the hydrogen and oxidizing agent. What happened there? Just this is done through a pair of redox reaction. As previously we have discussed that for the electrochemical cells we use the redox reaction. Similarly here we use the fuel that convert into the electrical energy through the redox reaction. So fuel cell is an electrochemical cell that converts the chemical energy of a fuel, that must be hydrogen or oxidizing agent, into the electricity through a pair of redox reaction. Now the fuel cell are different from most of the batteries is in requiring a continuous source of the fuel and oxygen. It means we require the continuous source of the fuel and the oxygen. Usually just we use the air. As we talk about the oxygen to sustain the chemical reaction. So fuel and oxygen just to get the chemical reaction, whereas in the battery the chemical energy usually comes from the substances that are already present in the battery. But here in the fuel cell we use the continuous source of the fuel as well as the oxygen just for the chemical reaction, and then it converts into the electricity. The fuel cell can produce electricity continuously for a long time, as well as the fuel and the oxygen are supplied to the system. So fuel cell can produce the electricity continuously for a long time or for a longer period as the fuel and the oxygen supply to the system. So fuel cell is a type of cell that falls under the fourth category of the cells. Those fuel cell are comparable to the batteries with the exception that all active components are not included in the devices as we include in the battery. Here we are continuously supplying the chemicals as fuel as a chemical, and the oxygen, and the and chemical reaction takes place inside a system, and that converted into the electricity. So first fuel cell were invented by the Sir William Grove in 1838. So the first commercial use of the fuel cell came almost a century later, following the invention of the hydrogen oxygen fuel. That was in the 1932 by the Thomas Bacon. So the alkali fuel cell, also known as the Bacon fuel, as it was invented by 1932. So the alkaline fuel cell, that is a Bacon fuel cell, after its invention has been used by the NASA for the space program since mid 1960s to generate the power or for the satellites and the space capsules. So since then fuel cells have been used in the many other applications. Fuel cells are used for the primary and backup power or for the commercial, industrial and the residential buildings, and in remote or inaccessible areas. So they are also used to power the fuel vehicles, including the forklifts, automobiles, buses, trains, boats, motorcycle and submarines. So, fuel cell can be used in many places. So, it has a very vast application of the fuel cell. So, now what fuel cell have and how it works. So, active materials are injected into the batteries from outside sources in the fuel cell. So, a fuel cell varies from a battery in that it can produce electrical energy as long as the active materials are delivered to the electrodes, but it will be shut down if these materials are not available. It means as we supply the active material to the system, the fuel cell will work. If it is stopped, then the fuel cell will stop. So, the use of cryogenic fuels in the space vehicle is a well known use for the fuel cell. Although recent developments have reignited interest in the range of the system, that applications such as utility power, load leveling, on-site generators, electric cars use the fuel cell technology for terrestrial application that has been slow development. So, nowadays we use the fuel cell for the batteries, fuel cell batteries for the electric vehicles also. So, these were originally developed for the space vehicles, however, recent developments have led to them being used in the variety of systems such as electric vehicles, utility power and the on-site generators. Moreover, the fuel cell can deliver the zero pollution and it is a eco-friendly, moreover having a high efficiency answer to much of our air pollution and global warming dilemmas. So, a fuel cell is an electrochemical power generator device that combines the hydrogen fuel with oxygen from air to produce electricity with water and heat as the only byproduct. So, now we discuss the how do fuel cell works. Basically, the purpose of the fuel cell just to produce the electric current that can be directed outside the cell to do work, such as powering an electric motor or illuminating a light bulb or a city. Because of the way of electricity behaves, this current returns to the fuel cell, completing the electric circuit. So, there are the several kinds of the fuel cell and each operates a bit differently, but in the general terms. Hydrogen atom enter a fuel cell at anode where the chemical reaction strips them of their electrons. So, hydrogen atom ionized and carry a positive electrical charge. The negatively charged electrons provide the current through the wires to do the work. So, if alternating current AC is needed, the DC output of the fuel cell must be routed through a conversion devices that is called the inverter. Now, you see in this diagram that there is a hydrogen from the tank, it is delivered to the system. Electrical circuit you can see here, the full circuit, you see the bulb here. Now, here we have the proton exchange membrane and one side you are having the right hand side you are the exhaust and upper side we have a catalyst and moreover these are used as a now you can see right hand side there is a oxygen from the air. It means we are supplying the oxygen in this tank. So, oxygen enters the fuel cell at the cathode end and in some cells types like the one we have illustrated above. So, if there combines with the electrons returning from the electrical circuit and the hydrogen ion that have travelled through the electrolyte from the anode. Means now we can see here that at the cathode we are having a oxygen enter in the fuel cell and hydrogen ion that travel through the electrolyte from the anode. So, through the electrolyte from the anode in other cell type of the oxygen pick up electrons and then travels through the electrolyte to the anode where it combines with the hydrogen ions. So, the electrolyte plays a key role and it must permit only the appropriate ion to pass between the anode and the cathode. If free electrons or other substances could travel through the electrolyte, they would disrupt the chemical reaction. So, the free electrons or other substances could travel through the electrolyte and it should be avoided. So, whereas whatever we are having in the when these ions are combined at the anode or the cathode together, hydrogen and oxygen from the water which drains from the cell. As long as the fuel cell is supplied with the oxygen and hydrogen, it will generate electricity. Once it is stopped, no electricity will be generated. Even better, since fuel cell create the electricity chemically rather than by combustion. So, they are not subject to the thermodynamics law that limit a conventional power plant. So, therefore, fuel cell are more efficient in extraction energy from the fuel. So, we can extract energy from the fuel just to get the electricity and waste heat from some cell can also be hastened, boosting system efficiency still further. Now, you can see on the screen a simple reaction provides the emission, that is a free power. You can see here hydrogen plus oxygen and here we are having a electricity power plus water vapor. Water vapor means water vapors are ejected. So, there is a combination of the hydrogen and oxygen, we will get the various type of fuel cell. Unlike traditional power generators, fuel cell are more fuel efficient, operate with a very little noise and produce a no harmful emission at point of the use. So, fuel cell and batteries are similar as they both generate the electricity. Battery stores the energy while fuel cell uses an external fuel such as hydrogen, allowing it to continuous operating as long as the fuel is available. Unlike conventional batteries, however, fuel cell do not contain harmful material and have a very little maintenance since there are no moving part in the fuel cell. Fuel cell is an electrochemical cell that reacts hydrogen fuel with the oxygen or another oxidizing agent. So, to convert the chemical energy to the electricity. So, if we talk about how it is different from the battery, that it requires a continuous supply of the fuel. Moreover, it produces a continuous electricity as well as the active material supplied to the cell. So, they are used for the primary and backup power for commercial, industrial and residential building also. In the remote area, we can use a fuel cell at a very low cost and moreover at a very environment friendly, moreover work in a efficient manner. They are also used to power the fuel cell vehicles including the forklift, automobile, buses, boats, motorcycles and submarines. Fuel cell are classified by the type of electrolyte they use, by the different in the startup time, which ranges from the 1 second to the proton exchange membrane fuel to the 10 minutes, or for the solid oxide fuel SOFC. Means we can just classify the fuel cell on the basis of its startup time as well as on the basis of is type of electrolyte what we are using. Type of electrolyte we are using, on the basis of we classify the fuel cell, and moreover the startup time means it is starting with a 1 second, as we take the example of the PEM fuel cell, that is a proton exchange membrane fuel cell, or it is start in 10 minutes as for the solid oxide fuel cell SOFC. So, on the basis of these cells are divided. Further we will discuss then how we get the various classification of these cells. Now, there are many types of the fuel cell, but they consist of three parts. Number one is anode, second is the cathode, and third is the electrolyte. You know that anode, at the anode, a catalyst causes the fuel to undergo the oxidation reaction that generate the protons, positively charged hydrogen ions and the electron, that is the anode. The protons flows from the anode to the cathode through the electrolyte after the reaction. So, at the same time electrons are drawn from the anode to the cathode through an external circuit producing the direct current electricity. So, another part is the cathode. At the cathode, another catalyst causes the hydrogen ion, electrons and oxygen to react forming the water. So, third part is the electrolyte, which allows the positively charged hydrogen ion, that is the protons, to move between the two sides of the fuel. Now, from this diagram you can easily understand, and this is very much clear from this diagram, that the hydrogen is just moving, and from the anode and cathode oxygen, and how these are combining and it produces the electricity. Now, you see fuel in and fuel out. The upper side we are having a fuel in, and electric current that is passed through the hydrogen atom is passed through it, and here air is passed from the right hand side, O2 and the other gases may be passed. Now, you see at the bottom on the right hand side, unused gas out, that is a waste, that so that it will not disturb the in the chemical reaction. Now, anode on the left hand side and cathode, anode having the hydrogen, and there is a combination of, and in between that there is a electrolyte, excess fuel will be get. So, these fuel cell works on the basis of the reaction between the hydrogen and oxygen. So, fuel cell are classified primarily by the kind of electrolyte they employed, and classification determines the kind of electrochemical reaction that takes place in the cell and the kind of catalyst required, the temperature range in which the cell will work or operate, or the fuel required, and the other factors. On the basis of we can classify the fuel cell. These characteristics in turn affect the application for which these cells are most suitable. It means we prepare a cell on the basis of that where we are using this cell in other places. So, there are several type of fuel cell currently under development, each with its own advantages, limitation, potential applications. On the basis of applications, on the basis of the active material, these materials are classified. So, fuel cell come in many varieties, like however they all work in the same general manner with the three parts: anode, cathode and electrolyte, active material supply. Until the active material supply to the system, it will work. When it spots, if we stop the active material pass through the cell, it will not work. And these anode, electrolyte and cathode will also used as per its application. So, two chemical reactions occur at the interface of the three different segments. The net result of the two reaction is that fuel is consumed, water or the carbon dioxide is created, and electric current is created. So, this can be used to power electrical devices, normally referred as a load. So, at the anode, the catalyst ion, the fuel, turning the fuel into the positively charged ion and negatively charged electrode. So, electrolyte is a substance that basically is designed so ion can pass through it, but the electrons cannot. So, electrolyte which we are using between the cathode and anode are used to pass the ions. You have seen there in the diagram that there is a H positive. You can see here in the diagram that this electrolyte which is having the ions in it. So, electrolyte are used where the ions can pass through it. So, another part is the freed electron travel through a wire creating in an electric circuit. The ion travel through the electrolyte to the cathode, and once reaching the cathode the ions are reunited with the electrons and the two react with the third chemical, usually the oxygen. So, iron and oxygen will attach together to create the water or the carbon dioxide. You can also see in this diagram that how it is work: anode, ion, electrode and this. Now, design features in a fuel cell. What design features we can have? The electrolyte substance which usually defines the type of the fuels can be made from a number of substances like potassium hydroxide, salt carbonate and the phosphoric acid. So, the most common fuel that is used in the system is the hydrogen, and the anode catalyst usually use the fine platinum powder and breaks down the fuel into the electron and ions. The cathode catalyst, often nickel, converts the ion into the waste chemical, with water being the most common type of the waste. Gas diffusion layer that are designed to resist the oxidation. A typical fuel cell can produce a voltage from 0.6 to 0.7 volt at a full rated load, and the voltage decreases as the current increases due to the several factors like activation loss, ohmic loss. Ohmic loss means voltage drops due to the resistance of the cell component and the interconnection. Next is the mass transport loss, means depletion of reactants at catalyst side under high loads, causing the rapid loss of the voltage. So, to deliver the desired amount of the energy, the fuel cell can be combined in the series to yield the higher voltage. So, to deliver the desired amount of the energy, the fuel cell can be combined into the series to yield the higher voltage and to parallel to allow a higher current to be supplied. So, such a design is called the fuel cell stack. So, the cell surface area can also be increased to allow higher current from each cell. So, these are the features where we can get the high efficiency of the fuel cell. We will discuss the type of fuel cell in the next lecture. Thank you very much.